Inverse of matrix method of solving simultaneous equation involves using the inverse of matrix idea in solving system of equations. So I'm going to make like 2 illustrations of how to do that in this video. So starting with the 2 by 2 matrix. Just consider this simultaneous equation, for instance. Yeah, so but before I continue with the main question, there is something I quickly need to inform you about, of which it will be of great relevance to what we're about starting. So if you have a matrix, so I'm supposing this equation is of the form Ax equals B, where x is the variable. So in order to get the variables, I will have x being equal to the inverse of the matrix and the B. So what does this illustrate? What this means is that I have multiplied the both sides of the equation with the inverse of the matrix. A is the matrix here, x is the variable. So this simply means that I have multiplied the left and right hand side of the equation by the inverse of the matrix. So it becomes something like this. So how do you apply this? I'm going to show you now in the video. If for this particular question, you write out the coefficients of the variables. So they are 3, minus 4, 2, and 1. So we have them like this. Then we have to get the value of d and x. So d x, you have it this way. So this is the matrix A, this A, and this is representing the x. Then we have equal to 10 and 3. 10 and 3 are the b's. They are the b. Alright, so in order to have just, dx is representing the x here. So in order to have this x alone, to have this dx that is representing the x alone, it means that we need to multiply this side and this side of the equation by the inverse of the matrix. So let's first of all get the inverse of the matrix, which is A inverse. So the inverse of that 2 by 2 matrix, because since A is 3, minus 4, 2, and 1, then A inverse would be 1, 3, then we have 4 minus 2. This is the adjoint or the adjugate, and the determinant of A is 3 plus 8, which is 11. So that means 1 over 11, because the formula for A inverse is 1 over determinant of A times the adjoint of A. So the complete solution for A inverse would be 1 over 11, 4 over 11, minus 2 over 11, 3 over 11. So none of it can be broken down. So having known this now, we can now substitute it. So for us to have the form of x A inverse this, for us to have this form x equals to A inverse of the B, the x is now D and x. Our A inverse is this 1 over 11 4 over 11 minus 2 over 11 3 over 11. Then the B is 10 and 3. So we are going to multiply the two matrices. Dx is equal to multiplication of matrix. We multiply this row with this column. So 1 over 11 times 10 plus 4 over 11 times 3. We are done with that. Then the last one, we use this row to multiply this column. That's minus 2 over 10 times, minus 2 over 11 times 10 plus 3 over 11 times 3. So that will give us 10 over 11. For this one, 10 over 11 plus 12 over 11 and this will give us minus 20 over 11 plus 9 over 11. So which will be, this will be 22 over 11 and this will be 11 minus 11 over 11, which means 20 divided by 11 is 2, minus 11 divided by 11 is minus 1. So from here, D is equal to 2 and x is equal to minus 1. So that's the end of the equation. So you can see that that is just the accurate answer. Okay, so this is another example. So we need to write out the matrix. The elements of the matrix are the coefficients of the variables. So 2 minus 1, we have 1, we have 3. So the variables are f and x. Then we have the 6 and 10. So in order to have just f and x, we'll multiply both sides by the inverse of the matrix. So let's get the inverse of the matrix. Suppose the matrix is K equals to 2 minus 1, 1, 3. So we need to get the inverse, which is K inverse. And the inverse is adjoint of the matrix K over the determinant of the matrix K. So let's get determinant of matrix K. Determinant of matrix K is 2 times 3 is 6. 6 plus 1, that's 7. So for the adjoint, for the adjoint is, we twist 3 and 2, that's 3, 2. Then minus times minus 1 is 1. minus times 1 is minus 1. So therefore, the K inverse will now be each of these elements divided by the determinant. That's 3 over 7, 1 over 7, minus 1 over 7,